So for the square hole in a square, no? So I did this. Did you do something similar?
Yeah, yes. So this was also something that I saw in between. So yeah, the observation is in that smaller square. That smaller square, the pieces over there would be like proportional to the pieces in the big square. That is on the left side. On the left side, you see that small central square, right?
Yes.
So the four pieces inside that small central square
are proportional to the big pieces. Yes, I agree. And also, see, in the process of this spinning, right? And this. And then, so this is the original outside of the square. And when I spin this, so this actually becomes the difference of those two. So this length.
Correct, yes.
And this length. Different of those two lengths becomes the side of the square.
Correct, yeah.
So this is essentially turning out to be, so here, remember we marked all the equal angles. So these are congruent. All the four big triangles here, four right angle triangles are congruent. And so that's why it ends up being that's why it ends up being a square in the middle. And also this is now a proof of Pythagoras theorem. This is now a proof of Pythagoras theorem.
How?
So this is so this white line is a hypotenuse, which ends up being the edge of the bigger square when we reassemble. And this vertical black line is A, which is the side of this square, and this, let's just call it B. So this small white square, the cutout, the hole, is B squared. So C squared plus C squared A squared
okay.
plus B squared is C squared.
Correct, yeah. Yeah, so I was actually also like thinking this would be like leading to Pythagoras theorem in some way, but I wasn't like able to figure it out properly. But yeah, now that you explained it, I think yeah, now I can understand it.
If we label these sides that way, and it turns out, but yeah, very very circuitous proof. So anything else you had on this?
Yes, I like written it down.
So in a rectangle, it turns out these triangles are not congruent but similar, and hence.
So yeah, like you also mentioned, right? That is that the side of that hole in the middle is effectively the difference between like the edge of like the length of those two segments.
Yes.
So I actually tried it out for a rectangle also. So for a rectangle, okay, just draw some rectangle. No, say just keep the length and breadth as 8 and 5.
I don't know 8 and 5. I will just scale it up here.
No, like just put some random number. So
okay. Too much.
So yeah, just I'm saying 8 and 5 because like I'll be using L1, B1 somewhere, so it'll be like very confusing. So
okay.
Just to have some fixed number. Okay, so now say you draw a random line that like something that cuts across the two horizontal lines. That is okay, the top line and the bottom line.
Got it. So
okay, fine. So we'll keep one line like this and the perpendicular line.
Yeah.
So how are you drawing this?
I'm using the set square. Is that set square not visible?
No, I can see it. Like I've never used it before, so like I'm just seeing how you're using it. So once you choose the set square, you can like draw lines.
Yeah, I am placing the set square on the rectangle. Then I'm using this cut.
Okay.
And that is magnetic to this set square.
Oh, okay.
Okay. No.
Right. So now it's like you basically have the okay, the two transversals. For a square, both of them would be equal. So here it won't be equal.
Correct. Yeah.
So yeah, so on the top, say you label the segments as D, and this the other part would be 8 minus D. So the bottom part would be like yeah, write it as 8 minus B and B. And here you just put it as C. And above, yeah, that will be A. So keep it as A and 8 minus D.
5.
5 minus
5. Okay.
So now if you are going to rearrange it, you will have a rectangular hole in the middle.
Okay, the labels haven't moved, but
So now the dimensions of the hole is going to be B plus D minus 8 and A plus C minus 5.
B plus D minus 8. Wait, let's go back to that. Okay. That will be okay. So, yes. B plus D minus 8.
So
and C plus A minus 5. Yeah, got it.
Right. So and the area of the bigger rectangle is effectively going to be the length and breadth of this big rectangle will be the length of the two transversals.
Yes, correct.
So yeah, basically now what will happen here is when we are kind of like say we choose the midpoint, it would the B plus D minus 8 will effectively be 0.
B plus D minus 8 would be 0. Yes.
So if you choose midpoints or like something which is like perpendicular,
yeah,
all the pieces will come together. So that hole will be of 0.
0. Yeah. Okay.
So,
okay. Yeah.
And now actually the length of the transversals will be proportional to the length and breadth of the original rectangle.
That's what makes these rectangles also be proportional to the original rectangle.
Yes.
Okay, how is that?
So 1 minute. What I did was I labeled the lengths of the different pieces. So yeah, just call that vertical transversal as L1. So the two segments as L11, L12. And the right to left L21, L22. Okay. So now the claim is L2 by L1 is 8 by 5.
Okay, so those two triangles, now that, so the lines that I've drawn, so this triangle and this triangle will have equal angles.
Yeah.
And are hence similar.
Ah.
So this will be the ratio of what is this? L. No, this will be 8. 8 by 5. So the hypotenuse, if you take, so L2 by L1 will be the same as 8 by 5. Yes. Which is why the outer rectangle has the same dimensions, has the same proportionality of the rectangle. How about the inner one? Okay. Okay, now that is nothing but this, the difference of those sides. So the difference of this and this is nothing but this, which is essentially the shortest side of the same triangles that we have seen, which are also in proportion. Yeah. Rhombus is another thing which gave rectangle.
So I actually tried it out for a parallelogram.
Okay.
So I actually did two things. One was I first drew like 90-degree lines.
Okay. Okay. So if we were to cut it with perpendicular line.
So now if, so I have these 4 pieces. Now if I rearrange, what do you think I'll get?
I don't expect it to work here.
Right. So yeah, you will not get a hole, but what will happen?
We will get an outer rectangle with some odd shape inside. Oh, wow. Wow. Okay. That's unexpected. Okay.
So actually, this is just the area of a parallelogram formula, except you made like.
No. Oh, okay. Because we have taken essentially the width and the height.
So in fact, only now I realize that in like showing the formula for area of a parallelogram, what we typically do is you cut off like the triangle at the end and bring it to the front. But actually, you can draw a straight line anywhere in the middle of the parallelogram.
Beautiful.
And it will give you the rectangle anywhere.
You can just, I mean, if we can take both these, just one cut is enough.
Correct.
Okay, nice. So now if it's not perpendicular to the one side, then what happens?
Right. So now we will label the parts over here.
Yeah.
So
you want me to label the parts or the corners?
Yeah. So you can label the parts and basically find the length of just write down the length of the different segments. So,
okay.
Just like we did A, 5 minus A and so on.
Right. Let's consider to be the same 8 and 5. So we've got.
I was using like 7 and 5, but yeah, it doesn't matter. So that I used as D for dot. And that would be 8 minus D.
Right.
So that is C. And 5 minus C. and the length of the traversals as L11, L11, L12, L221, L2.
Right.
So now, just keeping it in its place, you just rotate the one with L11 and L22. You just rotate it so that the 90-degree comes to the top right corner.
Yeah. Got it. Yeah.
And the bottom piece, again, you rotate it so that now the right angle comes to the bottom right.
So the L2 to L12, that one.
Yes.
Okay. Okay, done.
If you do that, the yes.
Okay, now.
Correct.
This is exactly like how we rotated the pieces in the square, no difference.
Yes.
Oh, beautiful.
So now, let me get this. So now the length of this big rectangle is going to be the same thing, that is L1 and L2.
Yeah, not the breadth of the parallelogram, but the height of the parallelogram.
Yeah, so basically the length and breadth of the rectangle is going to be the length of the two traversals. That is L11, L1 and L2.
Yes.
And so now the inside part, that smaller, the hole basically, it's going to be same thing as the rectangle.
Same proportions as the rectangle, but in a parallelogram.
No, same proportion as the original. No, I mean, what I meant was the same result that we got for the rectangle with the proportion for the hole. Same thing you will get here. So the length of this would be
B plus D minus 8. Same thing.
Yes.
Yeah. Wait, but I'm still not clear if it's proportional to length and height or length and breadth.
It's wait, I actually got this. So if your original parallelogram, the dimensions of like the length and the slant was 7 or 8 and 5. Now the dimensions of the hole would be 8 minus B plus D and 5 minus A plus.
Okay, so width of the parallelogram, not height.
No, I think like everything is going to be proportional anyway. So this hole is going to be like proportional to the original parallelogram that we start with.
Okay.
So basically the height of that hole is also going to be proportional to the height of like this parallelogram. So like everything of course is going
Agreed. Agreed. And the outer rectangle is proportional to length, and the length and breadth of the outer rectangle is going to be proportional to the length and breadth of the parallelogram we started.
Yeah, we can actually like write it down and check.
Yeah.
We basically won't get that right angle that we got for the rectangle and the square. For the square, we actually had like two congruent right angles, like one line flat and one upright.
Yes.
For the rectangle, we got two similar triangles. Like one is flat, one is vertical.
Yeah.
Here you will not get that right triangle anyway. Yeah, so it is actually not clear to me also if L2 by L1 is going to be like 8 by 5.
8 by 5 or 8 by the height.
So I think like some angles are same, but apart from that, it looks pretty random. So yeah. Like you can share the other problem that you are mentioning.
The other one was simple one only, but I thought we'll make the octahedron. So write 1 to 8 on each of the 8 faces of our octahedron. So that sum at the same sum of all the faces at a given vertex is the same at every vertex. So you remember how you made the tetrahedron by just folding it like you start a flexagon. So same way we can do octahedron also. So I thought we'll just make that and then try it out.
Yeah, I'm trying to solve this without making the octahedron.
Yeah. So I suppose the first step is figuring out what is that constant sum.
So the sum should be 18.
Sum should be 18, yeah. I also got sum should be 18. 6 times the sum by 3 should be 36. So 2 times the sum should be 36. So sum should be 18 now. Okay, so now we need to find different ways to add up to 18. 6 different ways to add up to 18. How are you doing it without the octahedron? We need to know which faces will meet at a vertex, right?
So I am trying to rule out. Okay, so I am kind of assuming there's going to be a pattern to it. Like say consecutive numbers are opposite faces or something like that. I am kind of assuming.
Oh, okay.
I think I have it.
Oh, okay. Okay, I still want to think about it. I have the quintuples, whatever, sets of groups of 4 that will give 18. 6 groups of 4 which will give 18. I have. Now assigning them to each face such that it works out in 3D space. I am taking some time with that.
So can you repeat how are you approaching the problem?
So once I figured out 18, then I found 6 ways of adding 4 numbers to 18 with the numbers 1 to 8. And it worked out nicely. 1 is coming 3 times, 2 is coming 3 times, every number is coming 3 times. So I'm happy with it. Now I have to assign these numbers to the faces such that it works out.
So I think here you will be able to see, like if 1 is not getting associated with any other number, that will be the opposite face of 1.
Opposite. Okay.
So 1 will basically have
okay, it will be on the other hand.
3 numbers adjacent to it.
Yes. Yeah. So I've got all, the way I've written the sums, I've got all numbers coming with 1, all numbers coming with 2. So this is wrong.
Right. So, like, what combinations have you got?
Okay.
So, I am also getting many of the combinations that you have got. The difference is you have 8163 and 4572, right? So I am getting 8145. No, yeah, 8145 and 4563. So
that also I have that also.
Yeah. So I also have 2358.
2358. Okay.
And 1476.
Five, 12, 18.
Right. So, yeah, so those two things I am not getting.
Okay.
So I think from like the combinations I have given, you will be able to figure out the opposite side.
Okay.
The opposite face of one and so on.
Mm.
So yeah, actually we can make the octahedron also.
Mm.
So how are you planning to do the octahedron? Like,
So I just did the same way that you started the tetrahedron and just folded it in a different way with lot of help with sellotape from sellotape. It's possible to make.
Okay. I mean, like now that I was thinking about it, I was thinking of this way. Yeah, at least for this problem, you can just consider like square. Yeah, basically I'm just taking this square and
Oh, right.
just to get the idea of the both sides.
Oh, okay, yeah. Make 2 copies of this and we have. This will take me time. I will work on this.
Okay.